All right, welcome to the Explainer. Today, we are going on a really fascinating journey through Google Cloud. Our goal here is taking you all the way from the foundational steps of managing just a single, solitary virtual machine, right up to orchestrating massive, self-healing, automated fleets. Whether you're prepping for your Associate Cloud Engineer exam or you're just looking to level up your cloud architecture game, you are in exactly the right place. Okay, let's dive into this. Here's our game plan for today. First, managing single virtual machines. Second, snapshots and custom images. Third, mastering the command line. And finally, scaling with instance groups. Basically, we'll master the single machine, learn how to clone it, command it all with code, and then scale it into an automated fleet.
Before we really get going, I want you to just keep this fundamental question in the back of your mind. How do you manage a single server versus a fleet of thousands? Because the tools and, honestly, the whole mindset required for that micro level are very, very different from the macro level. And today, we're going to bridge that gap.
All right, kicking things off with Section 1, Managing Single Virtual Machines, the basic unit of the cloud.
The life cycle of a VM is actually pretty fascinating. It's not just a simple on or off switch. When you stop a VM, you're actually pausing your compute billing, which is fantastic for saving money. But keep in mind that your SSH access is completely disabled. Then, start brings it right back to life. But take a look at the reset option. This restarts the VM, but, and here's a crucial exam tip for you, when you reset, the contents of your memory are totally lost. Your persistent disk data stays safe, but the RAM is entirely wiped. And finally, delete just releases all your resources for good.
Now, as your inventory grows from one machine to, say, 50, finding what you need becomes a total chore. Luckily, the Cloud Console gives you some seriously powerful filtering tools. You can filter your VMs by name, labels, IPs, status, you name it. The really important thing to remember here is that if you apply multiple filters, like let's say a specific zone and a specific label, both of those must be true for the VM to show up. It acts as a strict AND condition unless you explicitly type out the word OR. If you really want to supercharge these individual instances, you're going to want to attach some GPUs. Graphics processing units offload all those heavy math calculations from the CPU, which is absolutely essential if you're running machine learning models. But there are some strict constraints you definitely need to know. First off, your OS has to have GPU libraries installed, and Google actually provides specific deep learning images just for this. Second, the CPU platform has to be compatible with the GPU you choose. And third, GPUs cannot be attached to shared memory machines, no exceptions.
Moving right along to Section 2, Snapshots versus Custom Images, or how we copy disks.
Okay, let's draw a hard line right here, because people mix these up all the time. Snapshots and images are both copies of disk contents, but they serve totally different purposes. Snapshots, those are for your data. They're incremental backups, meaning after the first full snapshot, Google only copies the data that has actually changed since the last one, which saves you a ton of money on storage. Images, on the flip side, are a single, complete backup of a boot disk, and their whole entire purpose is to act as a blueprint to spawn brand new, identical VMs.
But think about this. What happens when that perfect custom image you built gets old? Say you built an image on Ubuntu 18.04, and you want your whole engineering team to move to 20.04. You don't just delete the old one right out from under them. Instead, you use image deprecation. This just marks the old image as unsupported. It warns users that it might not be getting security patches anymore, acting as a sort of gentle but firm nudge to migrate to the newer version before the old one is removed entirely.
Next up, Section 3, Mastering the Command Line with the G-Cloud CLI.
There's this really beautiful logical hierarchy to how this tool works. Every single command follows a really strict structure. It always starts with the tool, G-Cloud, then the service you're using, compute, then the entity, instances, then the action, like start, stop, or delete. And finally, the specific instance name and where it physically lives, its -zone. Once you wrap your head around this hierarchical syntax, it's like a language. You can guess almost any command in Google Cloud. And right alongside those commands, we have global flags that apply everywhere. Let me just highlight a couple of absolute lifesavers here. The -quiet flag disables interactive prompts and just accepts the defaults. This is completely perfect for automation scripts where you obviously don't want the system hanging there waiting for a human to type Y. And the -format flag? Incredible. If you need to export your VM inventory to another system, just slap -format equals JSON on the end, and it outputs perfectly structured, machine-readable data.
Finally, Section 4, Scaling with Instance Groups, or as I like to think of it, building your automated fleets.
Okay, we've got two flavors here, but let's be really clear up front. Managed instance groups are the absolute gold standard. They use a single template to create perfectly identical VMs that can automatically scale up when your traffic spikes and even self-heal if a VM randomly crashes. Unmanaged instance groups, those are strictly a fallback. You literally only use them if you're migrating some legacy system where your servers have mismatched, totally different configurations, and you just can't use a single template.
So, how do we actually build one of these automated fleets from scratch? It's a really precise three-step progression. Step 1, you configure your ideal base VM. Pick the OS, the disk, the machine type, the whole shebang. Step 2, you save that exact configuration as an instance template. Step 3, you deploy your managed instance group, and you just point it right at that template. From that moment on, every single machine that group ever creates is going to be a perfect clone of your template.
Now, to make sure this whole fleet is highly available, you're going to want a regional group, which spreads your VMs across multiple physical zones. But how does Google actually decide where to put them? Well, you set distribution policies. Even forces a strict, perfectly equal spread across all your zones. Balanced tries its best to be even, but it actually factors in what underlying hardware is currently available in the data center. And any? That just grabs whatever zone has the availability to spin up your instance the fastest.
This brings us to a massive, massive paradigm shift. Cloud computing and auto-scaling have eliminated the need for peak capacity planning. Really think about what that means. 10 years ago, a retail company had to buy wildly expensive physical servers in August just to handle the web traffic for the December holidays, and those servers literally just sat there idle for months. Now, you just set up a managed instance group. When the holiday rush hits, the group automatically adds servers in minutes. When traffic drops back down, it deletes them. It's a game changer. And if you want to optimize your fleet even further, you can utilize spot VMs. Spot VMs are just spare compute capacity that Google happens to have sitting around, and they sell it at a massive discount. Between 60 and 91% cheaper than standard VMs. You're getting an unbelievable deal. The catch, of course, is that they are preemptible, meaning Google can literally shut them down with almost no warning if they need that capacity back. But if you have a managed instance group running a workload that can tolerate a little disruption, this is an incredible way to scale your fleet for literally pennies on the dollar.
We have gone from clicking Start on a single machine to automating fleets of thousands of servers that self-heal and scale completely on demand. So I want to leave you with this final thought to take away from our explainer today. If the infrastructure is no longer the bottleneck, if you can literally summon and scale thousands of servers instantly with just a few lines of code, what limits what we can build next? The only limit now is the scope of your imagination. Get out there, open the Cloud Console, and start building.